When you present a card to a reader, the door unlocks. The reader has to send the credential data to the controller, and in many systems, that communication still uses a protocol designed decades ago. It's called Wiegand. In this video, I'll show you exactly how that data moves from the reader to the controller, step by step. Every access control system depends on communication between its components. We already understand the main flow: credential, reader, controller, decision, door. But between the readers and the controller, there is a communication layer. The reader must transmit the credential data. That's where Wiegand operates. It does not decide access. It does not verify permissions. It simply carries data from one device to another one. Understanding this layer is key to understanding how the system actually works at the signal level. Wiegand is a communication protocol used between readers and controllers. When a credential is presented, the reader extracts the credential number. Then it sends that number to the controller using Wiegand signaling. Important concept: Wiegand does not send decisions, it only sends credential data. The controller is still responsible for deciding where the access is granted or denied. Wiegand is simply the transport mechanism. Wiegand communication used two signal lines, D0 and D1. Each line represents a binary value. To send a 0, the reader pulls the D0 line. To send a 1, it pulls the D1 line. The controller listens to these pulses and reconstructs the binary sequence. So instead of sending package or structured messages, Wiegand transmit data as electrical pulses. After all bits are transmitted, the controller now has the credential number. One of the most common formats used with Wiegand is 26 bits Wiegand. These formats include 1 parity bit, 8 bits facility code, 16 bits car number, 1 final parity bit. The facility code identifies the organization or site. The car number identifies the individual credential. When a card is presented, the reader sends these bits one by one through the D0 and D1 lines. The controller reconstructs the number and checks if access should be granted. Credential technologies can vary: under 25 kHz, low frequency, 13.56 MHz, high frequency. But the reader acts as a translator. It reads the credential internally and outputs a number using Wiegand, which means card technology and communication protocols are not the same layer of the system. The name Wiegand originally referred to a card technology from the 1970s. Those cards use magnetic wires to generate pulse. Modern systems no longer use that technology. Today, Wiegand refers to a communication protocol, not the card itself. Understanding this avoids a very common misconception. Wiegand became widely used because it is simple and reliable, but it was designed in a different era. It does not include encryption, authentication, device verification. It simply sends raw credential data as electrical signals. You might think 34 bits is more secure than 26 bits, but it isn't. It only increases capacity, not security. What matters is what happens at this stage. After the reader processes the credential, the data is no longer protected. It is just electrical signaling. And if someone interacts with this communication, they are not attacking the card, they are interacting with the system. This is something we will demonstrate later in a control lab, but more importantly, this is only one part of a large picture. In real-world systems, attacks don't happen in just one place. They can target the credential, the communication, or the system itself. And even if one layer is secure, another one might not be. In the next video, we break down this layer by layer and show where access control systems actually get hacked. If you work in access control systems, you will encounter Wiegand. Understanding it helps you see how data moves between devices, where trust boundaries exist and where vulnerabilities might appear. Let's do a quick recap. The credential, reader, Wiegand, controller, decision. Wiegand does not make decisions, it delivers data, and that data is transmitted in a plain electrical signal. Wiegand is extremely simple. 2 wires, electrical pulses, binary data. And that simplicity is why it became the standard. But it's also why modern systems are moving towards more secure communication. Wiegand is still widely used, so understanding Wiegand is a key to understanding how access control systems actually work.